It's a pleasure to be here. Thank you for attending the session. So as most of you are here today, you probably have an interest to be able to deploy private cellular in your environment, or probably in the middle of a journey for deployment, or already deployed it and continue to scale in your environment. So it's high level, we're going to discuss the Purdue model, touch bases on it for a little bit. Then we'll dig into our journey, some of the lessons learned, and then some of the education involves some of the security risks that we discovered in private cellular, and then how we were able to address that to wrap up the session. So the Purdue model, as we all know, has been around since the 1990s. It's a way to be able to kind of have a framework to be able to segment our networks between our business and our process. And then just having a DMZ in the middle to be able to kind of have a stopgap, and then just allow different communications to traverse. So we have a lot of common applications that sit there. We have on the business network, of course, our web servers, DNS servers, and then the process with controls, we call our crown jewels. We have our PLCs, QCS, and DCS systems. And then as far as traffic is concerned, in the IT/OT environments, communication goes through multiple switches, different cores to be able to relay up to where it needs to go. But when we deployed our private cellular environment, which is about a little over a year and a half ago, we realized that everything kind of sat on the same network, right? So there's lateral movement. We don't have any visibility of what's taking place in that environment, as well as having just one common core where all the traffic is basically the traffic through. And so we saw that there was a gap there, that the Purdue model was not able to be implemented in the private cellular environment. And one of the lessons learned, we were excited about deploying private cellular, and it's something that we didn't think about initially early on, was being able to think about security. So we were excited to get the private cellular environment up and running, but after the fact, it was more so now to be able to have visibility in a Purdue-like model of what was taking place in that environment. So touching both bases on the Purdue model, we're all very familiar. This is a nice diagram to show some of the segmentation. So we use actually in the DMZ to be able to segment our two different networks for process and business. We use a 4-net firewall, and through the firewall, we're able to just create certain policies for to allow the common communications that are needed to be able just to get the data. So everything's locked down. And then to reinforce that, the firewall policies also have security profiles that are provided through the 4-net firewalls. And then you can see how that having this nice architecture and deployment is not the same in the private cellular environment, and why that could be challenging. So it's something that we wanted to make sure we were able to also find a solution for. So starting off with our education journey, why we wanted to pursue private cellular. As technology continues to grow, same thing with our businesses, continuing to evolve. We want to make sure that we have a way to not just kind of depend on one form of networking, so Wi-Fi, to be able to have connectivity for our systems. So we all have remote locations, or locations where it might be hard to run infrastructure for Wi-Fi. So some of the new technologies we wanted to pursue included private cellular, and as well as maybe even leverage satellites. But one thing we wanted to make sure after the fact of deploying our private cellular from the business aspect and viewpoint was to be able to make sure that we have a way to be able to secure it, that it performed well, and we had visibility for what was taking place in the environment as well. So our use case initially started off, we have warehouses, basically managed with very little human interaction. So we have AGVs, automatic guided vehicles, and LGVs, laser guided vehicles. So you don't have humans in those environments. The vehicles run on their own. It's very rare that they go down. If they do, then you can basically drive it off to a certain location and kind of maintain and fix the issue that it's having. Start off with that, and we went through a phase approach to be able to for our deployments. And phase 2 was basically adding on more additional devices on the private cellular network, which included, you have your cell phones, tablets, and laptops. But one lesson we learned as well, the environment today for the ecosystem doesn't natively support private cellular. So you're having to use routers or third-party devices to be able to get that connectivity. And with that, now you have another additional asset that you have to support. And outside of the assets themselves, the private cellular vendor is pretty much we have to highly dependent on, right? We rely on them to make sure their infrastructure is up and running. If we have any issues, we got to rely on them to be able to tell us what they found from the logs and what to be able to help resolve that issue. And so doing through those lessons, we wanted to make sure we found something, a way to be able to resolve that. We got to build that knowledge within our group of people, our networks and our teams, as well as being able to have knowledge shares, right? So what we're doing today, as many of you are in this room. Same thing that I kind of touch bases on for the security concerns, right? Not having the visibility, not able to prevent the device from communicating with each other, not knowing the performance for what's taking place with the devices. So a lot of the stuff that we heavily rely on today, we don't have. So as we progress through these slides here, you might see your name out here, but like many new technologies, early on, it takes time to adopt, right? People have to have forums, knowledge shares, conferences to be able to kind of learn more about that particular technology. As time goes on, more and more people were leveraging private cellular in their environments, and it's not just concentrated like where we come from pulp and paper, energy industry, you have oil and gas, and it continues to grow. And in the last couple of years, you can see a lot of key names are on here, leveraging private cellular. So digging through our research, we were able to figure out how they were leveraging private cellular in some of the use cases to help kind of grow our knowledge in-house as well. So starting off, we looked to see what the US industry was doing. So we kind of saw private cellular being deployed in the manufacturing area for cars. And what they were doing is basically using common applications and emphasis on machine learning. Similar to what we saw in our environment, there were issues with the same security, right? You have this deployed, but you don't have visibility to your devices, the performance, any anomalies that might be taking place as well. And then being GP, so we're under the Coke umbrella of company. So we have a lot of fellow other sister companies around the world. So we wanted to see from a global aspect what was taking place in Europe as well. They primarily use this for remote operations with the cranes. There's similarly a common theme along with the US, the visibility aspect of their devices and performance was common, and the segmentation being a key aspect of what was missing in the solution. So dig more into our journey as well as our proof of concept. So we initially were approached about, hey, what can we do to kind of get a foothold in what might be the new technology that is emerging currently today with private cellular. So the business is, besides just the pulp and paper under Coke, we're looking to see if there's a way we can deploy new technology for connectivity of our devices and our infrastructure that was cost effective, didn't take as much time, and then also see if there was a way to better perform than Wi-Fi. So as I mentioned, it included Wi-Fi, satellite, and even private cellular. To me, initially early on about private cellular, I thought it would be like our telephone providers, the AT&Ts, the Verizons, and the T-Mobiles, where basically there's a tower and it's just broadcasting the signals for your connectivity with your SIM card. So I assumed that this particular vendor was going to, drop a tower in the particular area and kind of just broadcast the coverage for what we needed to within our facility. But that wasn't the case. So today it still kind of relies on our infrastructure. So you still have your IDF cabinets, you still have your switches. It kind of relies on our backhaul of our infrastructure to have connectivity. But where we saw an advantage was reducing the number of access points. So in Wi-Fi, you pretty much do a survey, then you place the access points to be able to know what coverage you needed in that particular area. Handoffs are seamless, and you have connectivity with no downtime. What we saw was a great performance was we went from having about 20 access points in this particular warehouse down to 2 radios for private cellular. So we stuck one on each wall, got it hooked up, and we did a hybrid model where we deployed, we had an on-prem server that ran the VMs for the infrastructure, and then the actual core was in the cloud. So with that, and then tying that in, having an interface on our firewall to allow the connectivity out to, beyond our network to reach out the vendor's private cellular environment. So GP being a leading company, a lot of people look to us from our sister companies to do proof of concept, and then kind of waiting on us to kind of do lessons learned, right? What did you guys learn? What can we do to basically kind of on the tailcoat do the same thing in our environments? So in our particular lab, we started off with an AGV. We had a fleet of 3 AGVs, and we got them connected. Those AGVs don't natively have connectivity with cellular, so we had to leverage routers and leverage the SIM cards that were provided to us by the private cellular vendor. First thing was, can the vehicle still run? And then we did basically a timeline of how the vehicles ran on Wi-Fi compared to private cellular. Battery life, mission times, did it have any performance with being able to run its missions as well as delivering product. Then phase 2 was, all right, we can poke a hole into our firewall, allow connectivity from our IT OT network. So within the DMZ, we had a fleet manager to be able to manage the fleet of vehicles and see if it can traverse into the private cellular network. So with some modifications with routing, we're able to prove that that was actually feasible as well. And we ran that for about a month just to see there was any performance issues. We played around with taking down a radio, seeing how much coverage the vehicle had before it stopped to be able to run its mission. And likewise, just seeing if there was any connectivity issues, what those problems were. So having to work with our private cellular. Again, we didn't have the same tools that we do in our IT/OT environments to be able to just log in ourselves or put a ticket in to just view what's needed for the data. We had to rely heavily on the vendor. And as the third phase, we decided to add an additional router and then connect vibration sensors to be able to see, be able to broadcast from the router, the cellular coverage to the vibration sensors. Had those on the vehicles as well, had some temperature sensors, just seeing how those were accommodating to the private cellular environment. But the main thing that we got feedback from our business leaders was to make sure the performance wasn't an issue, and then finding a way to address the security concerns that we came across after the fact. Again, having to heavily rely on the vendor, we want to be able to take some of that stuff in-house, similar to what we do in our IT OT networks today. So now we're going to kind of discuss from the research. So we did the proof of concept, and now we wanted to also tie in what are other companies doing and what were the risks for using private cellular. So starting off, in our environment, so following the Purdue model, we're able to segment our assets, being able to kind of view what's taking place. So these are kind of fundamental building blocks for, we have the framework and then kind of tweaking it to our own advantage and our risk tolerance to how we deploy our assets today. We're able to have security teams in place from the enterprise level to kind of monitor if there's any attacks that are trying to take place on our networks, anything that's talking out that shouldn't be talking out, and then reaching out to our customers and then addressing those issues in-house. We were able to see our assets, where they are, where they're located, because one thing you want to do, being a large organization, you have assets deployed out there, but then if you don't know where they are or where they're located, you can't protect them. When it came to the private cellular environment, those building blocks were missing. Just to kind of give you a visual of what was the gap that we had, and we wanted to make sure we addressed before we did any more proof of concepts or scaling. So including the risks that are already available in the IT/OT networks, private cellular also included some more additional risks. And so some of those common ones include signal storms, particular IP attacks on the private cellular devices, DNS hijacking. So some of those are common in our IT/OT environments, but they're also expanded on in our private cellular. So that ecosystem that you have, everything's talking to each other, and you can't prevent it, right? We didn't have any way to know the performance of those assets. So we were in the market now to find a way to address those. Some of the common ones that we saw across the board for customers and other enterprise level companies for having issues with private cellular included these MQTT hijacking, IP attacks, signal storms, DNS hijacking, APN attacks. The most common one that I'm used to is DNS hijacking. Just the fact that you have this let's say a cell phone that we had in our environment, if it has internet connectivity, it can go to any website, right? And so let's say it was compromised, and now this cell phone went to it, now our other assets are compromised as well, and we had no way to see that. Same thing with the DNS server being compromised, and we've heard stories over the years for different large companies that we use or leverage their services for experiencing this. All right, and then now digging into basically our venture out to find a vendor or a solution to be able to address those security gaps. The common things that we were looking for, being with our warehouses, having a fleet of vehicles, was geo-tracking, so being able to kind of know and locate where our vehicles, what they were doing within their warehouse remotely. We wanted to be able to segment additional devices. If we have any humans that are on site, their laptops have connectivity to cellular as well, and their cell phones. We want to be able to kind of segment those and then also have visibility on what's connected if something else that we didn't expect to be on there. But the unique thing about private cellular is depending on the vendor that you go with, the SIM cards are provisioned ahead of time. So when they deliver to you, only you have access to that particular private network. Anyone else that walked by and tried to have connectivity wouldn't be able to. So that was the one way to be able to have security in your private cellular environment. And so it's a lot different from what we have with our telecom providers. So the company that we came across, from knowledge sharing our proof of concept, some of their sister companies were doing research, came across OneLayer. And we were able to have a conversation to be able to see what their solution provided. So after having some internal discussions, as well as discussing with OneLayer, we're able to decide to do a proof of concept to be able to deploy their solution on top of what we have in our private cellular environment today. And so that was the key pitch there, was being able to have the same Purdue model visibility in our private cellular environment. So we were able to decide on a proof of concept and then kind of get an environment set up. So it just included 2 additional servers, and they were able to remotely configure those. And we also integrated with our Fortinet firewall. So the interface that we had our private cellular network connected to, they were able to just listen to that particular interface and kind of monitor some of the traffic for early detection of what was taking place in our environment before even coming on site. So that was key to be able to kind of see a benefit in that. So they're like, hey, you have 3 devices connected today. And that was the case. We happened to have a town hall that day. We were doing a show and tell, and we had 3 vehicles running. So they're able to detect that ahead of time. And they were able to track also the vehicles where they were located in our warehouses. So it's about 3 segments, sections of the warehouse that we have in our particular facility that we did the proof of concept, and they're able to see each vehicle remotely where it was located. So now we had that segmentation, the visibility, and the geofencing that we were looking for location tracking. Then the next phase was being able to kind of set a date where they can come on site. So they brought their team, and we were able to add additional devices on the network just to kind of prove out the solution. So the first part was the discovery phase. So we had tablets, we had cell phones, we had PCs, we had routers, and the vehicles. So that was a range of fleet of devices in various forms, so cell phones and iPhone, Samsung. We had different routers to be able to know different manufacturers. So the first thing that we discovered in that discovery phase was their database. They have about 300,000 plus devices that was classified, so the ones that we had were automatically detected. So they were able to pull that in through a dashboard. Once they showed us the dashboard, we were able to see those devices there. And so that was a pretty cool part because we didn't have the visibility before. All we knew is we put these SIM cards in these devices, and by labeling it, that's the only way we had to track and to be able to know what was tied to what. And following after that, the classification, so it was a different screen where it allowed you to be able to see by the manufacturer what it was, a router. It could be a Beck, it could be Blink. And then anything tied behind those, you can drill in deeper to be able to see those devices as well. So all those sensors that we had tied behind the routers was also detectable. We could create policies. So the policies we played with was the fleet manager and our IT to OT network to talk into the vehicles themselves. We wanted no communication from the cell phones that had internet access to the vehicles. So if there was anything like that that was seen, it was alerting, and then being able to enforce policies to block that. to be able to stop that traffic. So we did a lot of playing around during that week of them being on site and then kind of seeing, hey, everything that we were looking for that we had the gap in, it was now basically being resolved. So this is a picture of basically in real time what we saw when we deployed our private cellular environment at the top section. So we had these devices, they had the SIM cards, right? But it was a blind spot. So if you went in and swapped the SIM card from a vehicle that was connected to a router, if you swap those SIM cards, you'll know that that particular SIM card IP address is tied to that asset, but we wouldn't know that the same policy was being enforced. And then so leveraging their technology, we're able to know from the dashboard, once you unplug a SIM card and plug it into a different device, it'll say, hey, this came from a cell phone. This particular cell phone had internet access, but now it's on this router. But with their policy and their technology, it's not just tied to the SIM card, it's tied to the actual device profile. So it makes it unique. Where beforehand, it's just we know that this particular IP address is coming into the firewall, and we wouldn't be able to enforce if it was swapped by someone physically on site. So that was an additional layer of security there. We had the segmentation with the policies. We had the alerting. So everything that we were looking to solve for was basically addressed. So it was some good lessons learned, and now we're looking to scale to a different facility to enforce that same technology. So a bigger warehouse, it's about 30 or so radios now, and then having a mass fleet of vehicles. So versus the 3 or 4 that we had on site, now there's a fleet of 30 plus. So we're going to have additional devices on there, include sensors. We're going to have cameras, and then we're going to see how this next phase plays out as well. Outside of the visibility, we're able to now also have performance monitoring of those assets. And then prevent that cross-lateral movement that was the key thing that we were looking to solve for. So earlier I mentioned the common attacks that we came across from our research in the private cellular environment. And with being able to leverage technology, all these items were addressed. So to wrap up, the building blocks that was detected early on, being able to apply that in the private cellular environment, now you can see was covered from deploying the solution. So that security gap that we're looking to cover, the visibility, the cross-segmentation, the lateral movement, all that was addressed. And then being a large corporation under the Coke umbrella too, and our sister company is looking to deploy private cellular, the particular private cellular vendor we use necessarily doesn't have to be used by them as well. So one layer is able to integrate with many different private cores. So we were happy about that from a Coke level, knowing that we don't have to be tied down to one particular private cellular provider. So that's key because across the industry, we touch many different things. So outside of pulp and paper, oil and gas, et cetera, et cetera. So that was a big win there. So I think that about ties it up. So definitely thank you for your time. I know I finished a little early, but